Hello everyone, welcome to VMS class. In this lesson, we are going to learn how to apply lasso regression for feature importance prediction. So in the last lesson, we have seen how to apply the ridge regression for car price prediction problem. Now, in this project also, we are going to use the same kind of data set, which is car price prediction, but we are going to apply lasso regression. There are mainly three types of regularization techniques are there. One is lasso regression, another one is ridge regression, and third one is elastic net. Okay, so basically the ridge regression is mainly helpful for reducing the coefficient values of the particular features. But the lasso regression is going to select some of the important features, or we can say it is going to reduce the feature coefficients to zero. Okay, that is a basic concept. Okay, I am not going to much details about the theoretical explanation. So this video main intention is to show you how to apply the lasso regression for a particular data set, and how can you train a model, and how to evaluate the model which is trained on lasso regression. Okay, so we are going to learn here what is lasso regression, how lasso regression performs feature selection, the difference between linear, ridge, and lasso regression. So in this example, I am going to apply three different models. Okay, linear regression, ridge regression, and lasso regression. I will apply these three regression models on the same data sets. I am going to compare the results. Okay, and in this, even we can see how to encode the categorical columns and how to apply the feature scaling, that is using the standard scaler. And we can compare all these three regression models and how this lasso regression is going to identify the important and unimportant features and understanding the zero coefficients in lasso regression. Okay, so that is the main agenda of this topic. So we are going to learn about three different types of regression models in this project. Okay, so for this, first we are going to import the data sets. Okay, whatever the libraries we need, so that we are going to import. So for this project, we need to import the pandas, matplotlib, okay, sklearn model selection. We are importing the train underscore test underscore split. Here we are going to import three models. One is a linear regression, ridge regression, and lasso regression. Then to apply the scaling, we are going to import a standard scaler from preprocessing. Now for evaluation metrics, I am going to consider mean absolute error, mean squared error, and R2 square. Okay, so now you can see this. Let's execute this cell. Now let's upload the data sets. So click on the upload option, then upload this data set. Once this file is showing in the Google Drive, then you can execute the second cell. You are going to load the CSV file df equal to pd.read underscore CSV car price assignment.csv. I am going to display the first five records from the data set. You can see that there are totally 26 columns are there. So if you want, you can see the complete data set shape using df.shape here. So there are 205 comma 26 columns are there. Now if you want to check the missing values, so you can use the df.isNull method, so that you can see what are the null values are there. Okay, then now I am going to select some of the useful columns for the model training. So out of this, some of the columns I have selected, as we have selected 22 columns in the last project also, the same logic I am going to use. Now, the next thing is here this data set is having some of the categorical columns. You need to convert that into numerical columns. So for this, I am going to perform the encoding process using the get dummies method. So then I am going to print the top 5 rows from that data set. You can notice that the new columns are added. Okay, I am using one hot encoding here. If you use this get dummies method, so the internal kind of conversion is nothing but one hot encoding. Okay, so now you need to select the input and output features. Okay, so out of all the columns, okay, totally we have 22 columns. Except the price, the remaining all columns are considered as input features, and price column is considered as a output feature. So now you have to split the data set into training and test parts. So this is the like method which we are going to use for splitting. So totally 20% is used for testing and 80% is used for training. Okay. So all these points we have covered in the last lessons also. So please watch our previous videos to get more details on the previous cells execution. Okay. Now, so since the range of values for the particular features are different, so I am going to apply the standard scalar here. Okay, I am creating an object scalar. So scalar dot fit underscore transform. So the input is the x train. So now the data is going to be scaled, that is going to store in the x underscore train underscore scaled. So now the for the test data also I am going to apply the same thing, transform x underscore test underscore scaled. Now we are going to train three different models. One is linear regression, second one is ridge regression, and third one is a lasso regression. I am going to train three different models and comparing the results. Okay. Now the first thing is a linear regression. I am calling the linear regression class constructor. Now one object is created. So linear underscore model dot fit. I am passing the scaled train dataset x underscore train underscore scaled, so passing the labels. Now we are going to predict on the test data. Okay, so all the predictions we are going to store in the linear underscore pred. Okay, now so these results are stored in the linear underscore pred. Okay, let us write the logic for a ridge regression. Okay, for this we are going to use the ridge regression. Okay, alpha you have to pass 1.0. So now the model is okay, created, and I am going to train the model here, ridge underscore model dot fit. I am passing the scaled trained data and labels I am passing. Now with the ridge model, I am going to predict on the test data. Okay, so this is the actual way of training and predicting the ridge regression. And the next thing is training the lasso regression model. So for this is our main task for this project. So here I am going to use lasso. Okay, so you need to pass the alpha, and I am passing the maximum iteration also 10,000. So now the model is created. Now for that model I am going to train. I am passing the x underscore train underscore scaled data. I am passing the labels. Okay, so now the model is ready. Okay, now on this model, lasso underscore model, I am going to predict by passing the test data set. So now the predictions are stored in the lasso underscore pred. So now three different models I have trained. Okay, linear regression, ridge regression, and lasso regression. Now, this is the logic for evaluation of linear regression. Mean absolute error. I am passing the y test actual values, linear underscore predicted values using the linear regression. So, I am calculating the mean absolute error, mean square error, R2 score. Okay, so here we are going to calculate with respect to linear regression. And next, we are going to calculate the evaluation metrics on the ridge regression. So in the same way, we are going to pass y test and ridge predictions to the mean absolute error. Similarly, y test and ridge predictions to the mean square error, and similarly y test and ridge predictions to the R2 square. So these are the evaluation metrics for the ridge regression. And similarly, lasso regression we are going to evaluate. Okay, so the same functions I am passing y test, but now I am passing the lasso predictions. Now here I am printing the lasso regression evaluation matrix. Now I want to compare all the three models together here. Okay. So now here this is a small logic which we have written model comparison. I am creating a data frame. So model. So three different models are there: linear regression, ridge regression, and lasso regression. Now for the mean absolute error, so I am creating another key value feature. So which is linear, ridge, and lasso MAE. And for MSE, linear, ridge, lasso, MSE. And for R2 score, linear, ridge, and lasso, R2 square. So now I am going to execute this cell. You can get a data frame something like this. Okay. So you can see the comparison of three different models. One is a linear, ridge, and lasso. You can see the what is the MAE values, MSE, R2 square. So you can notice that whichever the model is having the lowest MAE and lowest MSE, that is the best model, and the highest R square, which is the best model. So from the results, you can compare. So linear regression and lasso regression are performing better when compared to the ridge regression. Okay, so the same thing I am going to plot with the help of a chart. Okay, so here I am going to use the model comparison data frame from that model with respect to R2 square. Okay, only R2 square I am showing here. So now we can see that the comparison between these three models. These three models are like competitively working, but compared to ridge regression, linear and lasso are performing better. Okay. The next question is, how can we get the coefficients of this lasso? Okay. So lasso regression is going to reduce, or simply it is making the coefficient values almost to zero, so that the feature importance will be done, right? So now here I am just displaying what is the feature and coefficient values. Now you can see this is the feature and coefficient values. Just I am displaying the top five because I am using the head. Okay. Now count zero coefficients. So how many coefficients are zero? So now here zero features, okay, equal to in the lasso coefficients. So if the coefficient value is zero, so then that will be taken. And now I am going to select those features whichever the coefficient values are zero. Now you can see the total features are 41. Okay, selected features are 39 and removed features are 2. Okay, lasso regression is going to remove two unimportant features. Okay, now here I am going to display what are the features that was removed. So now you can see that cylinder number 3. Okay, fuel system IDI. So these two are like the coefficient values are 0. That's why we are going to remove these features from the data set. Okay, lasso regression main purpose itself, it is going to remove the features. Okay, remove the features for which the coefficient values are 0. Okay, it is going to make the coefficients to 0. Then after it is going to remove that feature from the original data frame or data set. Okay, so now here we are going to display the selected features. Okay, here we are going to display all the other selected features. So how many features we have selected? So totally 39 features are selected. So you can see these 39 selected features. Okay. So also just here a small logic we are applying. So some feature coefficient values can be negative. So we are taking the absolute coefficients and we are displaying all the coefficient values here. Okay, and in this you can see some numbers are high, some numbers are low. So let us sort all these coefficient values and you can identify which features are best. Okay, now if you see this graphically, so these are the feature coefficient values. You can see that engine size, okay, and cylinder number 4, okay, cylinder number 6. Okay, all these are like the coefficient values which were plotted here. So this is basically we can say the feature importance, which features are having more importance. Okay. So now this small logic I am going to plot the comparison between actual and predicted price using lasso regression. So just I am going to display the plot. Okay, you can notice that the blue color, okay, points are the actual price and red color are predicted. So you can notice that most of the points are very near together. So those are like the predictions which are most similar or which are most near to the actual values. Okay, actual value and predicted value, the distance will be very less. Okay, for few points, the distance will be more. Here, finally, I am going to take one of the test value from the X test. Okay, I am taking the very first value. So for the first value, we are going to predict how this lasso model is going to predict. So here I am using lasso underscore model dot predict. Okay, the samples car which is scaled value. So now here I am printing the actual value and predicted value. So this is the predicted price 28,602. The actual price of the car is 3760. Okay, so like this you can predict the car price for the new samples also. Here I have taken any one sample from the test data set. Okay, so coming to the final insights here. Okay, so we are going to just perform these three different types of regression models here. Okay, and in which the main focus is lasso regression. So when I am training and evaluating the lasso regression, even I am going to show the comparison, okay, between this lasso ridge regression and linear regression also. The main concept of this lasso regression is some feature coefficients may become zero. So here we got two features coefficients are zero. So those coefficient which are having zero, that features can be removed from the data set. Okay, here you can see the zero coefficient features are considered as less important. So lasso helps to reduce the model complexity. So by reducing these coefficients to zero, then lasso is going to help the models to reduce their complexity. But what happens in the ridge regression, basically it is going to reduce the coefficient but not going to make it zero. Okay, that is the difference between ridge and lasso. And this lasso regression is widely used for feature selection. So when you want to select important features or you want to remove unimportant features, at that time you can use this lasso regression. And it is also used for finance prediction, car price prediction. In this example we are predicting the car price itself. Even you can use in healthcare analytics, customer analytics, risk prediction, and high dimensional data sets. We can use this lasso regression. Okay, so that's the basic idea. Try to take the same data sets and execute this project so that you can get better idea. Okay, some of the points I have covered quickly. The reason is in the previous videos I have taken much time to explain the exploratory data analysis also. Please watch those videos also for better understanding. Thank you. I will see you in the next lesson.